Good day everyone, welcome. Today we'll be discussing frictional force, more specifically forces acting at a horizontal surface. Before we start, we are going to be defining some simple terms. Now, friction is simply the force that opposes motion. A rough surface, friction F opposes motion. That is, when we have a rough surface, friction opposes motion. A smooth surface, motion is free from friction. Now, when you have a question that say the surface is smooth, we are assuming friction is negligible. Also, R or N is the normal reaction between two surfaces. Coefficient of friction mu is equals to F over our reaction. When slightly take place or about to take place, our frictional force is equals to mu, the reaction, and forces acting at horizontal planes may be classified into two. That's our normal forces moving along the plane and our forces which is inclined at an angle to the plane. Our very first question is from NECO 2005. It states that while pulling a log of wood, a boss exerts a force of 40 Newton at an angle of 35 degrees to the horizontal. Find the effective force pulling the log along the ground. Now, the force P used to pull the log along the ground has both vertical and horizontal components, but the effective force pulling the boss along the ground is the horizontal component of the force P. Now we know that when resolving forces, our horizontal component will be P, that or the force cos theta. So therefore it will be equals to P cos theta, which is equals to 40 cos 35, which will be approximately 32.77 Newton. Our next question states that a force P is 46.67 Newton. If it is inclined to the horizontal at an angle of 50 degrees, find its horizontal component. Our very first step is to represent our question in a diagrammatic form, and when we do that, we get the diagram as shown on the screen. Now this question is pretty straightforward, as we are only asked to look for the horizontal component of P, and from our knowledge of resolution of forces, we know that when a force is inclined at an angle to the horizontal component is going to be that force times cos the angle. In this case, our PS, which is the horizontal component of P, will be equals to P cos 50, which therefore will be equals to 46.67 times 0.6428. Multiplying our PS, or our horizontal component of P, will be approximately 30 Newton, and our correct option is A. We have another question from WAEC that states that a block of mass 15 kg rests on a horizontal floor. Its coefficient of friction is 0.45. What minimum force is required to just make the block move when pulled horizontally? Take G to be equals to 10 meter per second square, and we're given the option. Now the very first thing to do is to represent our question in a diagrammatic form, and doing so we get the diagram as shown on the screen. Now the minimum force required for the body to just start moving will be equals to the frictional force. So therefore P will be equals to F, and we know that F is equals to mu n, where so therefore P will be equals to mu n. Now to get our reaction, N will be equals to 15 times 10, which is equals to 150 Newton. So therefore P will be equals to 0.45 times 150, which will be equals to 67.5 Newton, and the correct option is C. We have a question from November 1992 that states that a body of weight W Newton rests on a rough horizontal plane. If the coefficient of friction is mu, find the least force acting at an angle of theta to the horizontal that will move the body, and we are given the option. Now our very first step is to represent our question in a diagram, and doing so we get the diagram as shown on the screen. Now at the point of moving, F will be equals to mu Newton, and at the point where the body just starts moving, the sum of all our horizontal forces will be equal to 0, and all our vertical forces will be equal to 0. So beginning with our horizontal forces, the sum of Fs, which is our horizontal forces, will be equal to 0. Now in our question we have two horizontal forces, which is F, our frictional force, and P cos theta, the horizontal component of P. Since they are both in opposite direction, F minus P cos theta will be equals to 0. So therefore F will be equals to P cos theta, and mu Newton will be equals to P cos theta, since F is equals to mu Newton. This will be our equation 1. Now for our vertical forces, sum of Fi, which is all our vertical forces, will be equals to 0. Now the vertical forces we have in our question is the vertical component of P, which is P sin theta, N and W. P and N are both going upwards and W downwards. So therefore P sin theta plus N minus W will be equals to 0. So P sin theta plus N will be equals to W. This will be our equation 2. But from equation 1, we know that N is equals to P cos theta divided by mu, and we're going to be putting it into equation 2. So therefore equation 2 becomes P sin theta plus P cos theta divided by mu is equals to W. So multiplying through by mu to clear fraction, it becomes mu P sin theta plus P cos theta will be equals to mu W. And factoring out P at the right hand side, it becomes P in bracket mu sin theta plus cos theta is equals to mu W. Dividing both sides by mu sin theta plus cos theta, we get P to be equals to mu W divided by mu sin theta plus cos theta, and our final answer is E. Our final question is from November 2000, and it states that a force of magnitude P newtons is applied at an angle 30 degrees to the horizontal on a particle of mass 5 kg placed on a rough horizontal plane, which causes it to move. Given that the coefficient of friction is 0.2, calculate P. Now our very first point of action is to represent our question in the diagram, and doing so we get the diagram as shown on the screen. Now we know that P has both vertical and horizontal components, and at the point where this body just begin to move, the sum of our horizontal component will be equal to 0, and the sum of our vertical component will be equals to 0. Now beginning with our horizontal component, the sum of Fs, which is our horizontal component, will be equal to 0, and our horizontal forces F minus P cos theta, which is the horizontal component of P, will be equals to 0. These are our only two horizontal forces. But at the point of moving, F is equals to mu N. So therefore it becomes mu N minus P cos 30 will be equals to 0, and P cos 30 will be equals to mu N. We know that mu is equals to 0.2, so P cos 30 will be equals to 0.2 N. Cos 30 is 0.8cc, so it becomes 0.8cc P is equals to 0.2 N. This is going to be our equation 1. Also, the sum of our vertical forces will be equals to 0. So our vertical forces are P sin 30, the vertical component of P, which is acting upward, N, and W, which is acting downward. So P sin 30 plus N minus W will be equals to 0. And we know that W will be equals to 5 times 10, which is equals to 50. So imputing, it becomes 0.5 P plus N is equals to 50. This is going to be our equation 2. Now solving equation 1 and equation 2 simultaneously, we know that from equation 1, N will be equals to 0.866 P divided by 0.2, which should be equals to 4.33 P. Now put N equals to 4.33 P into equation 2. Equation 2 becomes 0.5 P plus 4.33 P will be equals to 50. Adding our P together, it becomes 4.83 P is equals to 50, and P will be equals to 50 divided by 4.83. So therefore P will be equals to 10.35 Newton. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshop, or if you are interested in the soft copy, you can get it at the website at the bottom of the screen. Thank you.